Myself, Rajendra Karali. My qualification is MSc Chemistry BA and experience is of 28 years. Now today we are going to discuss about most important concept of the chapter, that is hybridization. First we discuss about the definition of hybridization. Suppose let us consider one of the wall is there. Suppose you want to paint it. We have one bucket and it requires 4 bucket paint. Suppose we have one bucket red color and 3 bucket blue color. Suppose one bucket red color is used first, then 1/4 wall become red color and 3 bucket blue color are used, then the 3/4 wall become blue color. This is the first method for coloring the wall. Second method is that suppose one bucket red color is mixed with 3 bucket blue color, you will get 4 bucket of uniform color. And this concept is nothing but the hybridization. That is, hybridization is nothing but the process of mixing and recasting of atomic orbital belongs to what? Valence shell of having nearly same energy belongs to what? Valence shell of same atom to form equal number of new orbital of equivalent energy maximum symmetry and definite orientation in space. Now listen here. Hybridization is the process of mixing and recasting of atomic orbitals having nearly same energy, belongs to the valence shell of same atom to form equal number of new orbitals with equivalent energy, maximum symmetry and definite orientation in space. That means this definition is directly compared with this example. Now here the new orbitals are formed. The new orbitals are called as hybrid or hybridized orbitals. Now here Linus Carl Pauling and Slater introduced the concept of hybridization of atomic orbitals in order to explain the characteristic geometry of polyatomic molecules and valencies, observed valencies of certain elements. Now here write down steps involved in the process of hybridization. Here first step is that this topic is only for MBSE 11 and MHT-CET, but it is also useful for CBSE, NEET and JEE. Here the first step is that formation of an excited state. Now here excited state of an atom is formed only when if the number of unpaired electrons in the valence state is less than valency of an atom. Now listen here. The excited state of an atom is formed only when number of unpaired electrons in the valence shell is less than valency of an atom. Now what is the definition of excited state? Now the excited state of an atom is nothing but the state in which electron pair in the lower energy level is uncoupled and one of the electron is promoted from lower energy level to higher energy level. Now let us consider EC of carbon in the ground state is 1s2, 2s2, 2p2, that is your 2px1, 2py1 and 2pz0. That means here now let us observe here. Carbon atom have two unpaired electrons in its valence shell in the ground state, but carbon is tetravalent. Valency of carbon is 4. That is here carbon is tetravalent. That means here electron pair in the lower energy level is uncoupled and one of the electrons is promoted from lower energy level into the higher energy level, meaning is that from 2s into 2pz. That means here EC of carbon in the excited state is C6, that is 1s2, 2s2, 2s1 and 2p3 here. That means 2px1, 2py1 and 2pz1. Electronic configuration of carbon in the ground state indicates that carbon atom have two unpaired electrons in its valence shell, but carbon is tetravalent. That means here number of unpaired electrons in the valence shell is less than the valency of an atom. So you can form the excited state. How the excited state is formed? The electron pair in the lower energy level is uncoupled and one of the electron is promoted from lower energy level into the higher energy level, and you will get electronic configuration of carbon in the excited state. And in the excited state, carbon atom have 4 unpaired electron in the valence shell. Now your second step is mixing and recasting of atomic orbital. Now your atomic orbital belongs to valence shell of excited state of an atom are mixed up with each other and redistribution of their energies takes place to form equal number of hybrid orbital of same energy. Listen here. Atomic orbitals belongs to the valence shell of an excited state of an atom mix up with each other and redistribution of their energies takes place to form equal number of hybrid orbital of same energy. Now here the bond formed using these hybrid orbitals have same strength because they have same energy, and the process is called as hybridization. Now we have hybridized state of carbon, that is 1s2 is the inner shell, therefore this is remain as it is, and your 2s and 2p atomic orbital are mixed together and here you will get 4 sp3 hybrid orbitals, and here type of hybridization is sp3. Now then next, atomic orbitals participating in the hybridization should have same energy. That means here atomic orbital belongs to the valence shell of same atom have participate in the process of hybridization should have same energy. That means here atomic orbital belongs to the valence shell of same atom participate in the process of hybridization should have same energy. That means here example 1, mixing of 2s and 2p atomic orbital is possible due to small difference in energy. Small difference in energy means this 2s and 2p atomic orbital have nearly same energy. Second, mixing of 2p and 3s atomic orbital is not possible due to large difference in energy. Now, then next, fourth step, formation of hybrid orbitals or which is also called as different types of hybridization. Now here number of hybrid orbitals produced is equal to number of atomic orbitals involved in the process of hybridization. Now here write down case 1. For sp3 hybrid orbitals are formed when one s and 3p atomic orbitals are hybridized and the process is called as sp3 hybridization. Case 2, 3 sp2 hybrid orbitals are formed only when one s and 2p atomic orbitals are hybridized and the process is called as sp2 hybridization. And case 3, 2 sp hybrid orbitals are formed only when one s and one p atomic orbitals are hybridized and process is called as sp hybridization. Now then next step, proper orientation of hybrid orbitals in space. Now let us consider when 1s and 3p atomic orbitals are hybridized, you will get 4sp3 hybrid orbital, and the hybridization is called as sp3 hybridization. But how these 4sp3 hybrid orbitals are arranged in space? Now, all the hybrid orbitals are identical in their energy content and directional character, but they may differ in their orientation. Now here hybrid orbital get arranged symmetrically in space in the space around the central atom to have minimum force of repulsion between them and maximum stability. That means it gives definite geometry to the molecule. That means these are the 5 important steps involved in the process of hybridization. First step is the formation of an excited state. Second, mixing and recasting of atomic orbitals. Third, atomic orbital participate in the process of hybridization should have nearly same energy. Fourth, formation of hybrid orbital, that means different types of hybridization. And fifth, proper orientation of hybrid orbital in space. Now here write down characteristics of hybridization. Now here first characteristics, atomic orbitals participate in the process of hybridization should belongs to the valence shell of same atom or ion. Second, atomic orbital participate in the process of hybridization should have nearly same energy. Third, number of hybrid orbitals form equal to number of atomic orbitals involved in the process of hybridization. Then fourth, hybrid orbitals are identical in their energy content and in directional character. Fifth, hybrid orbitals are differ from one another in their orientation. Then next, geometry of hybrid orbital is different to that of atomic orbitals. Then next, each hybrid orbital can hold 2 electrons with opposite spin. Then next, a hybrid orbital have 2 lobes on the 2 sides of the nucleus. Now here one lobe is large and other lobe is small. Now then next, hybrid orbital are more effective for forming stable bond than pure atomic orbitals. Then next, hybrid orbital form stronger bond this is because hybrid orbitals are concentrated in one particular direction in order to achieve greater overlapping. Now, hybrid orbitals have maximum symmetry and definite orientation in space so that mutual force of repulsion between electrons is avoided. Then next, hybrid orbitals are directed in space in some preferred region to have stable arrangement hence type of hybridization represent geometry of the molecule. Now here write down next. Conditions for hybridization. Here atomic orbitals participate in the process of hybridization should belong to valence shell of same atom or ion. Second, atomic orbital participate in the process of hybridization should have nearly same energy. Third, atomic orbital participate in the process of hybridization may be half filled or completely filled. And fourth, promotion that means excited state is not the essential condition prior to the hybridization. Now this is regarding about hybridization, its definition, steps involved in it, characteristics of hybridization and condition for hybridization, and remaining part of this unit will be discussed in the next lecture.